This is the story of how chronic jaw pain led me to quit my 9 to 5 to make it as a product designer, and how after $40,000, 4,000 hours, 190 prototypes, and countless sleepless nights, I made it happen. I turned my apartment into a mini factory with boxes stacked to the ceilings, 3D printers buzzing 24/7, and one happy 23-year-old who gets to improve, hand assemble, and ship his own product to hundreds of people overlooked by the market. I've been documenting every step of the way on this channel, but I've never had the chance to tell you the full story. From how I came up with the idea, why I thought I could pull it off as a brokey 2 months out of college, how I designed my first PCB, and all the challenges that came with prototyping an electromechanical device, how I got my first customers, through how I scaled the product, its marketing, and production to $50,000 a month without a single investor and zero prior experience. I really wish I found a video like this when I first started dreaming of designing products, because I think I would have started a lot sooner. So hopefully this is interesting to some of you guys, and if you have any questions, let me know. I'll be answering to all the comments. Except wait, I already kind of lied to you guys. Saying I quit my 9 to 5 is a big oversimplification, and honestly, I think it's a pretty discouraging one to people who aren't the biggest risk takers. So I thought I'd give you the full lore, because the real story of how I ended up as self-employed is actually kind of funny and a little embarrassing. As a quick background, I always wanted to start a business, but kind of just in the same way that anyone wants to start a business one day. I keep a long list of product ideas. I've listened to 1,000 hours of how I built this, my first million, Alex Hormozy. But what can I say? I'm lazy. I'm not one of those people that started 6 side hustles before they were 18. It was more of a, I'll get there when I get there kind of deal. Although the dream did impact my education. I liked the idea of building consumer products, so obviously I'd be an engineer. And early on I leaned into mechanical engineering, but still, I knew that pretty much no products out there were purely mechanical. So I forced myself to take as many computer science and electrical classes as I could. It was important to me to be able to understand the entire product design process. And because of this, I got pretty pushed away from the idea of being a mechanical engineer in industry. Like, really, I learned all these awesome skills just to spend weeks optimizing a screw for an airplane? No offense to my fellow mechie screw optimizers out there, but it would have felt like a sunk cost. I needed a job where I could somehow oversee the entire product, which unfortunately left me with very few options. I didn't want to apply to places like Tesla or Lockheed, but I also didn't know what companies I did want to work at. In undergrad, I interned all my summers at a drone motor company until I realized I had no interest in drones. So as I got closer and closer to graduating, this became a bigger and bigger problem. I applied to product design consultancies, like all of them, rejected without an interview every single time. I applied to 3D printer companies, rejected without an interview. Toy companies, robotics companies, rejected. I'm not gonna give you the whole list because you get the idea. My one saving grace, I found this new 5-person startup from a friend of a friend, which honestly, I was excited for. The idea was to build prefabricated accessory dwelling units, which is cool, but mainly I'd get to work on a V1 of a multidisciplinary product just like I wanted. Except one problem. I didn't even have a full-time offer. It was a summer internship with a we'll see what happens guarantee. But screw it, I'm the friggin' GOAT. I knew I'd get the offer, so I packed my bags and moved to Austin to see where it took me. At least I would enjoy my work. And I really did enjoy the work. I liked my coworkers too, but when I got the full-time offer, something just switched. For reference, I was one of 2 engineers. The other guy was just a year older than me and started a few months before me. But my offer? Junior mechanical engineer for $70,000. And I was boys with the other engineer, so I knew how much he made. It was a lot more than $70,000. So not gonna lie, I was pissed. Like, bro, what? Junior engineer? This isn't Boeing where you need some fancy management structures. I'm literally directly answering to the CEO. I'm working on the first prototype of the product. Junior engineer didn't sit well with me. And you know what the equity was? 0.25%. The company would have had to sell for like $100 million for that equity to actually make a difference in my life. And I'll be honest, I already noticed some cracks forming. I wasn't even sure the startup would even be able to raise a seed round. So I just realized, like, what the fuck am I doing? I just graduated from an Ivy League university, not working at Google or McKinsey or somewhere with actual prestige, making tens of thousands of dollars less than my friends, my title as a junior engineer, and what was the upside? 0.25% equity? Truly a little embarrassing. That's when I decided I'd fly back to Philadelphia, where my girlfriend was finishing undergrad, split my time at her apartment and my parents' house for free, and use the time to design my first product so I could at least work towards my dream with full ownership. Except that's also a bit of a lie. I didn't go back to Philly completely unemployed. That would have been way too risky for my taste. Which is why I was lucky to have a friend who was already running a product business of his own, who let me come in and run the day-to-day for $40 an hour. I did a little design work here and there, but most of the job was pretty boring, straight up assembling and packing orders. But the important part was that I had a space where I could stay and prototype my own products for free until I could spread my wings and go out on my own. The moral of the story is people love to glorify quitting their job to start a startup. I do it all the time, but it's not the only way. If you want to start something, just find a job that gives you the time and supports your ability to build on the side. Only when you have a minimum viable product you're ready to ship should you go all in. I didn't have that yet. All I had was a... You've probably heard the saying that ideas mean nothing. All that matters is execution, and there's some truth to that. Without execution, you're guaranteed to fail. You can have the best idea, and without putting in thousands of hours into it, there's no chance you're gonna build anything worthwhile. But in terms of how much effort you'll have to put in to get that result, that's where the idea starts to matter a lot. You can either build a product on hard mode where you have to invest tens if not hundreds of thousands of dollars off the bat for designs, factories, patents, and certification, where you have to instantly rent out an office and hire employees, where you have to pay hundreds of dollars for shipping and storage, where you have to risk everything just to bring the product to market and then make no profit until you hit tens of thousands in sales because advertising costs too much. Or you can build a product on easy mode. As I said, I'm not much of a risk taker. It had to be the easy way or I wouldn't do it at all. This is a big reason I'm building myTMJ pen and not something else. It has a great backstory for marketing. It's small, meaning I can economically 3D print casings dozens at a time. I can fit all the components in my apartment. It's electromechanical, meaning the minimum order quantities with supplies are pretty low. Shipping is cheap. I can do everything myself, all without a cent of outside investment. And most importantly, it's a literal painkiller for customers in a market that had zero competition when I started. Even now, there's barely any. I'm sure I'll get kicked in the nuts for calling this easy, but seriously, of course I've had my share of challenges, moments I thought the business was cooked. But the point is, I've had room to breathe, experiment, and learn without risking much at all. And if you're confused, myTMJ pen, the product I designed and sell, is a portable heated massager specifically for people with chronic jaw pain, otherwise known as TMJ disorder. Originally, this was just another idea in my notes app, but at the same time I was dealing with my finding a job crisis, my TMJ disorder was getting worse and worse, to the point where my jaw would lock close almost every morning, and then for the last year and a half, it's been locked permanently. Heated massager are the most common at-home management tools recommended by doctors, and they save me in my most painful moments. Ideally, I just wanted something more convenient than microwaving a mug of water, and to this day, there is nothing out there that lets you apply massaging pressure simultaneously with hot pack level heat. I had a couple ideas battling it out for my first product when I moved back to Philadelphia, but quickly it became obvious how perfect myTMJ pen was. It fit that entrepreneur story to a T. Man experiences pain, finds nothing on the market, so he builds one for himself and others like him. So okay, great, I got the idea, except before I could even start designing, I had to answer one question. As I said, I studied mechanical engineering, meaning I've never designed a single PCB before. I'll admit that I have taken electrical engineering classes like a circuit design class, some lab electronics classes, some robotics classes. We even got into some Arduino usage in our Mechie curriculum. But it turns out that designing your first PCB has nothing to do with whether you can do nodal analysis for an op-amp circuit. In some ways it's easier, but in some ways it's also a lot harder. At first my mind was a bit broken by all the unanswered questions. What even is a PCB? How do you even start going about designing one? What software do you use? Where do you buy parts? Who manufactures them? How do I find the right components? How do I test them? And so on and so on. Luckily, this wasn't my first rodeo learning something new. I had developed something called YTIC, YouTube-induced confidence, because no matter what, step one is always watch a damn YouTube tutorial. I'll link some below, but there are a million. I already had a basic understanding of electrical engineering, and if you don't, just watch the basics. You pretty much just need to know V equals IR to start. For me, I learned what a PCB was. It's a sandwich of layers, some of which are conductive, some are non-conductive, some are just aesthetic, and those layers help connect together and organize all your electronic components. Simple. Okay, so how do you actually design one? Turns out there are only really two steps. steps. First, you create a schematic. This is where you port in all the components your board will use and draw out how they should all be connected. Step 2 is called the layout, where you make an outline of your board and then drag and drop your components where you want them to sit. Then it's just a game of connect the dots. It'll show you which pins need to connect together based on your schematic, and all you need to do is wire them up. You can also wire multiple layers of components and wires if things start to get tight. But how the hell do you even pick components? How do you find them? How do you know how to connect them up? To answer this, before I even touched a schematic, I needed to create a functional requirements list for myTMJ pen so that I can create a block diagram, which will help me narrow down an electronic components list. So okay, what did I need myTMJ pen to do? It needs adjustable heat, adjustable vibration, a bunch of indicator LEDs to show what state it's in. I need it to be portable, meaning battery powered and rechargeable. That's it, right? Well, here's where it starts getting complicated. Making a block diagram, we start with the power source, the battery. It's going to need to be rechargeable, so we'll need an external port and some kind of charging circuit. We'll need a way to turn the device on and off. We'll need a vibration motor, a heating element, but then I went and picked out the specific motor and heater I wanted to use, and turns out you need to run them off 7.2 volts. A battery only runs at around 3.7 volts, meaning we need a way to boost it up to 7.2. We'll also need driving circuitry to turn the motor and heater on and off. We'll need LEDs and buttons for user interface. We'll need a microcontroller to program and control everything, and another voltage regulator to supply constant voltage to it and the LEDs. But this is good. Once there's a block diagram, we just need to look for components that perform the task of the block. A lot of the time, you'll literally just have what's called an integrated circuit that does exactly what you need. For example, I looked at common charging chips for lithium-ion batteries. The TP4056 came up. Sure, then how the heck do you drive a vibration motor? Look it up. Boom, Stack Overflow. Here's a circuit that just needs a MOSFET transistor. Then I went to an electronic components database and searched for MOSFETs that would fit my specific voltage, current, and size constraints. To pick a microcontroller, I was really constrained by how many pins I needed, because just think about all these inputs and outputs I'd need to control, and price, of course. Some of these integrated circuits need a bunch of external components, which would be hard to design if they didn't literally tell you exactly how to pick out, place, and wire together every single component. Seriously, if you haven't done this, look up a video on how to read data sheets in circuit design. They tell you everything. But making that list of components is pretty much the hard part, because the schematic and layout is just connecting everything together. One of the biggest questions I get from you guys is what specific software and websites did I use to do all this, which is actually, I think, very valid, because looking back, I remember being very confused about this too. Originally, I used Autodesk Eagle, but it was kind of annoying to have to manually go online and find components and then download their information and footprints and port it into Eagle and then export everything again and send it to some random PCB manufacturer. But then I found this insane trio of LCSC, EasyEDA, and JLC PCB. I'm not sure how, but they're all somehow connected, where LCSC is a massive components database and seller, EasyEDA is the design software, and JLC PCB is the manufacturer. The combo is insane. EasyEDA is a free to use, easy to learn, it's online, you got the schematics, the layout, everything. You go to LCSC, find a component you want to use, and then you see this code, you go back to EasyEDA and click place symbol, search for that component code, and boom, it has all the part info filled out and the PCB footprint automatically downloaded. And you even have an entire online library of user-generated circuits, which are great for referencing or literally copy and pasting if they're the same IC, for example. And when you're done laying everything out, you just have to click and boom, it sends everything to JLC PCB to have manufactured for you. Oh, and the best part, the pricing on this stuff is insane too. I think it's because they have everything vertically integrated, because you can literally get boards made for less than $5 and even order them fully assembled cheaper than anywhere else I've seen, because JLC has all their components in their warehouse. And for transparency's sake, this video is sponsored by JLC PCB, but I swear I literally had to beg them to sponsor me because the trio has been so fundamental to me getting myTMJ pen off the ground. And I literally still use them right now for my production boards, so I'm hyped. If you want to start building your own, I'll leave links in the description. But yeah, thanks to us living in the age of $2 PCBs, I didn't have to do too much prototyping. I just ordered the board and oh boy, it turns out. Just look at what the V1 schematics look like versus the V10. Off the bat, I completely forgot to think about how I'll program the board. I was so used to using Arduino and ESP32 from college that I thought I could just program over serial, meaning I'd only need a TX and RX pin. No. I'm an idiot. Apparently the chip needs to come with something called a bootloader for that, so I had to figure out how to even program a microcontroller. I learned about the 6 pins you need for ISP programming, how you need one of these external programming boards, how you need to flash using the Microchip Studio software by exporting your Arduino code to binary. And by the way, yes, I coded with Arduino IDE. Some people wrote roasted me for it, but I don't care. It's what I'm comfortable with and it makes no difference. The code is really simple here. We're just turning on LEDs, PWMing the motor and heater, and checking for button clicks. To actually test the functionality of this first board, I had to solder wires onto this teeny microcontroller pins, but finally I got the board working, only for me to get a puff of smoke as soon as I tried turning anything on. Let me tell you a piece of advice that I still have trouble following to this day for some reason. If you have problems with your board, always check to see if you picked the right component. Because it turns out I picked out an inductor that totally couldn't handle the load from the motor or heater. Turns out I also picked out a boost converter that couldn't handle the load, and literally 10 months later on V9, I realized I also picked out a filter capacitor that couldn't handle the motor. So I redesigned and reordered again and again and again. Every redesign, I made some incremental improvements. For programming, I added the correct 6 pins, but then I realized that took up too much space and made assembly hard, so I found these 6-pin spring-loaded cables that could make programming very easy. I added battery protection circuitry to the board so I didn't have to buy more expensive batteries that already included protection circuitry. I added the ability to read voltage. I added electrostatic discharge protection. But I also had to make some major changes. For example, I sort of mentioned the way I was controlling the heating power was with PWM, essentially pulsing on and off super fast, where by controlling the percentage of on time, you can control the power output. The problem was I needed this on time to be very low or else the heater would just get way too hot and burn you, which meant it took an insanely long time to heat up, and when you touch it to your face, it would dump all the heat and not be able to maintain temperature. I realized I needed to know how hot the tip was so I could heat it full power until it reached a set point, and then just shut it off. But how would I measure the temperature? Well, the obvious answer is a thermistor. Basically, it's a special kind of resistor that drops resistance as it heats up. You can measure this resistance and with a little math figure out temperature. Except I'm an Ivy League engineer. What am I, just gonna use the obvious answer? No, I wanted to be clever. A thermistor would be a whole new component. It would be annoying to solder on and you'd have to wire it all the way to the tip, which would make assembly harder. And what if it got caught up in the vibration motor? So here was my idea. Normally when you pass current through a resistor, the resistance increases. So if you know the voltage and current, you can measure the change in resistance and therefore with a little math, figure out the change in temperature. To measure current, I learned that you can measure voltage across something called a shunt resistor. I was really excited about this solution when I ordered a prototype board. It's so neat, except when it arrived, I quickly realized I missed something extremely obvious. The voltage was barely budging because it turns out the heating element is made out of nichrome, a material famous for not changing resistance as it heated up, meaning to make it work, I'd need to amplify the signal and subtract it to be in range of my microcontroller input voltage. Long story short, I decided to just use a thermistor. So at this point, I had a board that was fully functional and I finally had a prototype that I could actually use for myself, which was super cool. But you know what's even cooler? Actually selling it. When are we gonna get to that? They say that if the first product you ship is perfect, you're shipping way too late. And I'm not a perfectionist. I was ready to ship out a V1 to customers that wasn't perfect, because that's the fastest way to get user feedback and improve while pushing the business forward. But there was still a flaw with the electronics that should never make it out of the lab. It's safety. You see, there are these things called failure modes, basically just scenarios that may cause your device to fail. Some failure modes are acceptable. For example, now that I sell hundreds of these, once in a while someone will come to me with their vibration motor not working. No big deal. I've replaced their device and try to figure out why it's happening to improve the design. But other failure modes are disastrous. For example, any that lead to a battery explosion, which I already designed around by adding protection and charging circuitry, brownout detection, and even venting. But the ones I didn't have covered were the ones that could lead the tip to overheat. Because to be able to heat up in a reasonable time, we had to have an overpowered heating element that we'd turn on and off based on temperature readings. But what if some component failed and caused it to be stuck on? It would get hot enough to burn someone's face. Seriously, unacceptable. Meaning every single possible component failure needed some kind of redundancy, some kind of backup. For example, what if the microcontroller crashed while sticking the heater on? For that, I had to add something called a watchdog timer that resets the microcontroller in the event of a crash. What if somehow the thermistor ended up breaking? Maybe the wires get disconnected or the leads short together. For that, I had to code the microcontroller to sense the thermistor voltage and shut it off if it was ever grounded or floating. But okay, here's another one. What if during assembly we forgot to stick the thermistor into the tip? For that, I added a safety timer that checked if a certain temperature was reached in a certain time and shut it off if not. But here's another problem. All of those safety features used a microcontroller. And what if this microcontroller broke and somehow the control pin got stuck on? Or what if the transistor that is used to drive the heater broke in such a way that it was always on? The microcontroller wouldn't be able to do anything to turn it off, even if it did sense something wrong. This was the tricky one to solve. The obvious idea was to use a thermal fuse, but there weren't any out there that tripped at the low temperatures I was at. And they were way too big. It took me weeks on forums trying to figure this out, but in the end, I came across this thing called a crowbar circuit, which is normally used by power supply units in case of overvoltage. My idea was basically when some voltage threshold is reached, you trigger a short circuit across a fuse that blows, essentially safely breaking your entire board. And I think the way I implemented it is actually pretty fun. Basically, I used a component called a comparator, to which I feed the voltage from the thermistor and compare it to a preset voltage. As the thermistor heats, its resistance drops, so the voltage goes up. Normally, the output of the comparator is 0 volts, but as soon as the voltage gets higher than the preset voltage, the comparator instantly switches to 3.3 volts output. That output goes to a component called a triac, which basically is a diode that only lets current flow through it if there's a high enough voltage on its trigger pin. Meaning as soon as that comparator switches on, the battery shorts to ground and a ton of current flows. Normally this would totally break the board, but that's why we have this fuse, which blows first and shuts off power completely. The best part is actually that this is called a polyfuse or a resettable fuse, meaning once current stops flowing, it resets itself, and voila! Even if this shutoff happens by accident, we just turn the board off and on and everything works perfectly fine. So now, no single components can cause overheating. Redundancy, baby! Which meant I was ready to order my first batch of 100 units and start selling. But wait, let's back up a bit. I've only been yapping about electronics. Are we just gonna ignore all the work I did? Building a product is never a linear process. Everything I just talked about with the electronics took months. Months where at the same time I was sprinting to try to finalize the mechanical design of myTMJ pen, something that I'm still improving to this day. Just look at all these prototypes, nearly 2 years of work on this table, so let's talk about it. They all kind of look the same, but I swear they're not. This right here was the first 3D print I did for myTMJ pen. It's called a looks like prototype, because I didn't even have any of the electronics designed. I had no idea how everything would fit together. But you can see I already had the idea that this would be a kind of pen shape with a tip that can apply pressure while having a surface area to apply heat as well. The hexagonality of it also stayed with us. The idea there was that hexagons are really easy to 3D print. They are also kind of unique and fairly ergonomic as well. If we look closer, you'll notice this little rubber part here. This will be part of a theme that any product designer will know, the fact that I started designing with a bunch of goals in mind that ended up being way too unnecessary for a minimum viable product. Remember how the goal was to get the product out to the hands of customers ASAP? Well, the rubber part was a part of my idea that the vibration should be mechanically unlinked from the casing so that the tip would vibrate on its own without vibrating the casing where you hold it. This was tough to do. It required a bunch more parts, more complexity, and quite frankly, I decided it didn't even matter that much. Do I get some people saying how it's uncomfortable to hold now? Sometimes, sure. But the vibration is literally a secondary feature of the product. It's mostly about the heat and manual massage. Why would I ever trade delaying sales, a more difficult assembly process, and a harder manufacturing process for a slight improvement on a secondary feature? So I scrapped that. I already had enough challenges ahead of me because it definitely took a couple more iterations to get this casing right. The main considerations were ease of manufacturing and ease of assembly. For example, minimizing part count is critical, minimizing cost, assembly time, all while improving quality and customer experience. So let's walk through my design iterations to get a better understanding. After a couple more failed designs, I got to something that was at least functional. Notice the buttons are in the right spot, and I already had the idea of letting the indicators shine through a super thin layer of plastic. I did realize here that I wouldn't be able to print in a light colored filament since the LEDs diffused through the casing, which was just so ugly. Also, notice the tip. This was my first design where I ordered from a manufacturer in China to be made in aluminum so I could actually feel the heat. Some of you guys ask how I source my parts. All you have to do is go to Alibaba and search for CNC aluminum manufacturers and get a quote from around 10 of them for your part to see who's the cheapest and best at communicating. It's that easy. Originally, the tip was supposed to be held in with a set screw, but this was a terrible idea. So I added these little grooves that would snap into the casing. It felt pretty satisfying, I'm not gonna lie. I also had to add this little inset down at the bottom that would be held against the casing to lock its rotation. But this design wouldn't last either. In fact, you'll notice it doesn't even have a space for a thermistor because this was before we added that to the PCB. Moving back to the casing, you'll see the way I was holding in all the components was with a snap fit. You'd snap the battery in, and then you'd snap the PCB in on top, and then insert the motor and plug in all the connectors and whatnot. And then in the end, I'd place the cap on top and screw everything together. Except I really wanted to find a way to get rid of all the screws, so I found a way to snap the cap in as well. This was all right. It was definitely very few components, which is good, but it was not elegant having to snap the PCB in from the top whatsoever. And a drop test didn't help either. When you're designing something, the way it usually goes is you start with this big block of marble, and that represents your idea. And then you just go and start hammering away at it, you know, chiseling away all the problems, all the bad parts, until hopefully one day you are left with just this beautiful marble statue that you're ready to sell. This was the statue I was left with, but it wasn't beautiful. It sucked. So I had to hit clear and just start redesigning from scratch. By the way, if you don't know how to use a professional CAD software, you need to get on it. There's no other way to design physical products. So after the redesign, we were left with this. First, you'll notice the tip changed again. This time, it's mostly rotationally symmetric, which makes it cheaper, and it had a little hole in it for a thermistor to sit. The casing had to change to accommodate this as well, but it also changed for other reasons. The battery would still snap in from the top, but now the circuit board would slide in from the front. This made assembly so much easier and reduced the risk of damaging components. That's why you have this funny little shape of the cap to cover up that front portion, but this meant we couldn't just snap in the tip anymore, meaning we had to bring back screws, which I was okay with this time since they'd totally secure the cap while also clamping down the tip and putting a physical block to prevent the thermistor from coming out of it. The buttons on the cap changed a lot over time as well. First, they started as little inserts that were just way too annoying to assemble. Then I tried making it a super thin bit of plastic that would bend to press the button. When that didn't work, I removed a bunch of material to leave only one little cantilever holding spot, which as far as clickability goes, worked great. They were also print in place, but goddamn they're ugly. Which is why my original plan was to cover everything with a super thin plastic graphic panel I'd get outsourced with membrane buttons and everything. But unfortunately, this was another idea I had to sacrifice for the sake of a minimum viable product, which is why you see I added this button cover I'd print out of 2 colors instead. The funny thing was that this was supposed to be a temporary fix just to ship out the first 100 units. And then I'd switch to the graphic panel. But printing everything in-house was just way too convenient, so I redesigned the button once again to what it is today. Back to the casing though, instead of being designed to be printed horizontally like they were originally, the casings were going to be printed upright so I could fit 50 of them on a single print. If you look closely, you'll also see that to keep the motor in place, I opted not to design some other 3D printed part that would screw in. Instead, I used the advantage of 3D printing to embed a channel inside the casing, which would let me run a zip tie through, acting as both cable management and a motor holder. I actually came up with this super early on in the design, and I think it's genius. This is the point at which I started shipping. As you can see, it was far from perfect, but it was good enough to sell. But before we merged the storylines with what happened after we ordered a first batch of PCBs to sell, I thought I'd show you the rest of the design changes too. The biggest challenge I faced mechanically was the vibration noise. You can tell by just how many prototypes are sitting here in this section. It was so damn loud, and the reason it was so hard to fix is because of just how many variables were fighting against me. First of all, the battery and PCB had to be sitting tightly as to not rattle. Easy enough, but what's holding them in place? The walls, which were pretty bendy and also had to hold the top cap in place. The top cap holds the button insert against the PCB, meaning when any of these components loosened up, we'd get a ton of extra noise. And it didn't help that the walls warped out sometimes after printing, making the cap not sit flat. But even after fixing all that, the vibration was still louder than it should have been. I thought maybe the zip tie isn't doing the trick, so I flipped the motor on its side to hold it in with more surface area. Failed. I tried screwing it in. Failed. I tried gluing it in. It kind of worked, but glue is awful to work with at scale. So I tried wrapping the motor in foam tape. It still just wasn't good enough. But then something crazy happened. I finally did it. I was playing around with tolerances when all of a sudden the rattling stopped.
Listen to how quiet that is. Come on.
When I tell you, I popped off. So I 3D printed a couple more just to make sure it wasn't a fluke. Put all the components in and nope, still rattled. How? What else was there? Turns out I had just gotten very lucky because I accidentally used one out of my 3 original prototype motors for that test that worked, as opposed to one of the 100 production motors, which I then happened to inspect and see that? Oh Oh my god. The shaft on the production motor is longer than the prototype ones, meaning the weight sat further out and applied a bigger vibration moment. That was a crazy find. From then on, I made sure all the vibration motors had a shorter shaft. But you know the crazy part? The motor was still louder than it should have been. Literally just this month, I was able to discover an underpowered capacitor on my circuit that was causing electrical motor noise. And I discovered I was running it at way too low of a PWM frequency, which produced an audible whine. Fixing all of this was a journey of its own, but you can watch the last episode if you want the details. So after all this, you can tell I'm still constantly learning and improving. Which, by the way, is why I think it's so important to be able to 3D print casings. Imagine if I had to buy injection molds at $10,000 a pop every time I wanted to make a change. I would be bankrupt.
Speaking of money though, that's enough engineering talk. Let's bring it back once again to what I had to do to get my TMJ pen out of the lab and into the hands of real customers. Because I had to get out of my comfort zone and start.
I don't even know where to begin here because honestly, I didn't even know where to begin back then either. I started with all the easy stuff pretty early on into prototyping. My LLC got formed in January, and same with my bank account. It's really basic stuff, but you gotta learn to keep personal and business finances separate, so if your business ever gets sued or something, they can't come after your personal belongings. A little harder though was abandoning the idea of going for a patent. Because for some reason, there's this idea rooted deep in society that you need to patent to launch your own product. It'll be your only shield against copycats stealing your idea. But if you just think about it from first principles, for most people, this is a ridiculous myth. A patent doesn't shield you from anything. All it does is give you the right to sue someone that allegedly copied your invention. Which means a couple major things. First of all, anyone can get a patent on anything if they're specific enough. The more rigid you make the claims of the patent, the easier and cheaper it'll be to write. Except at the same time, the easier it's going to be for a competitor to go around it and legally copy you. It takes a really good patent to be broad enough to truly protect the invention without getting into obvious territory and being rejected. And good patents are expensive, tens of thousands of dollars. But even worse, all it gets you is the right to sue, meaning if a competitor comes along, you'll also have to be dropping thousands of dollars on legal fees trying to take them down, hoping they didn't just find an easy way to get around your patent. Now just take a look in the mirror and think to yourself, what is the actual goal here? The road to a successful product is long, full of failure, and deep in learning. And my goal is to minimize my chances of regret, for which there are 4 scenarios. 1, I get a patent, spend tens of thousands of dollars of money I barely have at a time when I need it most, and then fail. That is my nightmare. 2, I get a patent and then succeed. My TMJ pen sells fantastic. In fact, it sells so well that competitors start to take notice. I get to drain the business account to sue some of them, except some of them are from China, so that doesn't even work. Guess I'll have to outcompete them in some other way. 3, I don't get a patent. I try to get my TMJ pen to market, learn a lot building the product, but just can't get it to sell. Okay. It sucks to fail, but at least I didn't lose any money and I learned a lot. And 4, I don't get a patent. My TMJ pen sells thousands of units, competitors take notice, now I get to learn how to compete. And by the way, in my mind, selling my first ever product so well that it starts getting copied is already a huge win. Out of those scenarios, the best cases are barely different, while the worst case from getting a patent is significantly worse. That's because a patent is only one of many ways to protect your product sales. The tens to hundreds of thousands of dollars you'll save can be used for developing better and newer products, hiring sales teams, branding, marketing, customer service. There are dozens of different sales channels and platforms and probably hundreds of different customer bases you can target. Look at Theragun, for example. They had a patent, and what now? Look at the millions of other massage guns out there. But they're still the premium brand. They survived and they thrived. At the end of the day, if you can't outcompete a knockoff, maybe just humble yourself and realize you just need to learn how to become a better businessman. I'm mostly just talking to the younger version of myself here because these were the thoughts I was wrestling with competing against the people saying, patent this year, you're just gonna fail. And of course there are exceptions. Amazon, for example, does a great job at shutting down knockoffs if you can prove that you have the original patent. So if you know that Amazon is the only way, sure, get a patent. If you're looking to get investors or try to quickly license out your product, a patent helps because those people have money to sue. Or of course, if you just made some big mega genius technology that no one has ever thought of, go for it. But other than that, patents are just for people that have a bunch of money to spare. I had about $25,000 saved up when I first went full-time with this business, which is either 6 months of runway or a piece of paper that's useless until I already am successful.
Also, the beauty of 3D printing your own casings and assembling in-house is that you don't run into the risk of Chinese manufacturers just straight up ripping your design off one-to-one. They'll have to do a little extra work to design their own, which they will never do until you prove that the product makes a bunch of money. And if you prove that, well, you just made a bunch of money, so what's there to complain about?
At the end of the day, I was planning on bootstrapping my TMJ pen. No investors, no licensing deals, and Amazon was never going to be step one. The business model that would have the lowest risk of failure was just setting up my own site and selling direct to consumer. Marketing using organic social media and advertising. Although I'd be lying if I said there was an actual business model written down. There were more... And the concept was pretty much throwing spaghetti at a wall to see what sticks. The first piece of spaghetti was a website, which also meant figuring out a brand name and logo. And the beauty of doing everything myself means I get to look back and see how much I've improved at design. Cause yikes. But it's fine, because my only real goal was to collect pre-orders. Actually, not even pre-orders, pre-order deposits, meaning they'd deposit $15 to reserve a 30% discount when we launched. I just kind of wanted to start building momentum, you know? At this point, I think we were on episode 5 or 6 of the series if you want to go back in time, so I started trying a couple things to get my first customers. First, every single YouTube video I'd post on both the TMJ subreddit and all the more engineering subreddits for people to follow the journey. I got a couple pre-orders that way. But the real funnel started when I created the myTMJ Relief Instagram account, which right now is at around 68,000 followers. But back then, I had no idea how to make good content. My plan was much more boots on the ground. First of all, I'd create a bunch of resources for other people with TMJ disorder, meaning blog posts summarizing research papers, articles with helpful relief tips, a bunch of tutorials for at-home physical therapy exercises. Then I'd post those to Instagram, which of course got 0 views, but then I'd go to big TMJ accounts, go to their comment section, and just spam follow all the comments because they were all people with TMJ disorder. A certain percent of those would check out my account, see the helpful posts, and follow back. I literally had to buy 200 followers because it was a bad look to have 0 followers and like 100 following. And then I also figured out how to go viral on the TMJ subreddit. Hint, just complain a lot. In every post, I'd try to sneak in a link to the Instagram so it wouldn't get flagged as advertising, but would still get them into my funnel. I got my first couple 100 followers this way, and from there, I literally DM'd almost all of them to try to get them to pre-order my TMJ pen.
First freaking order. It's only 15 bucks, but feels pretty freaking good.
I knew I had to double down, which is why around this time I started posting every day and haven't looked back since. Although I won't lie, I kinda lost my way. I just couldn't handle posting about TMJ every single day. My life simply doesn't revolve around the disorder. I don't want to complain about it every day. I don't want to write blog posts about it every day. That's not what I signed up for. I'm an engineer. My life revolves around building this product and building the business around it. So that's what I started posting about, the behind the scenes journey, and that's when the account really started taking off. My first viral video got me nearly 10,000 followers, and one by one I started learning what it took to make content that worked. Except the problem is now who followed me? Engineers, entrepreneurs, no TMJ patients. And look, 60,000 of anyone is better than no one at all. I 100% made the right decision to do what it took to post every single day, but that meant I'd have to find another way to sustainably get sales, which turned out to be meta ads. That's how I really started making some real money. But before we get to that, we have to pick up the story where we left off, with prototyping done, our first batch of 100 PCBs ordered, and a couple dozen pre-orders scraped together. It was finally... You know that feeling when you're in the Uber to the airport and you swear you packed everything, but goddamn, you just know in your gut that you forgot something. And hey, maybe you did, maybe you didn't. It doesn't matter, that feeling is still gonna be there. That's how unboxing batch 1 of the PCBs felt. I just knew something was going to go wrong. But it doesn't matter, I picked one out of the bubble wrap, snapped off the rails, loaded up the programmer. Everything was riding on this, which is why when those lights came on, I felt like a goddamn champion. Let's fucking go! The heater worked, the motor worked, all the safety mechanisms worked. It was actually happening after 11 months. The little idea from the Notes app. I finally get to ship it out to real, paying customers. It felt good. But we still had work to do. First, unboxing all the circuit boards, then soldering all the thermistors, printing out casings, and putting together the packaging. Which, by the way, you know how companies like Apple have perfected the premium unboxing experience? Well, I was on the complete other side of the spectrum. My first batch was shipped in a folding box filled with bubble wrap and stuck with a seriously terrible looking label. I did try to up the cuteness factor by shipping those first orders with a handwritten note and Kit Kats though, so pat in the back for that. But that's the beauty of shipping to those early customers. Remember, I had basically gotten them all through DM. I knew exactly what they dealt with. These first few units were personal, which gave me breathing room to ship something that wasn't perfect, something that is far from what it is today and what it's going to be in the future. You won't know the feeling of packing up and shipping those first orders until you do it yourself. It rules. But it meant more than just a feeling. Remember how at this point I was still working part-time for my friend and using his office to build? Well, I was getting pretty tired of packing and assembling his mini smoke machines. My TMJ pen was ready. I was ready. This was what I needed to... The plan was simple. I parted ways with my boy, bought my own 3D printer, moved my stuff out of my parents' house, and packed a car to move to Washington, D.C., where my girlfriend was starting her new job. I still had this first batch of 100 to sell through, but now that I was unemployed, my mindset shifted towards the future. This had to become a real business, which is why I had already started the redesigns for a second batch of 500 units. But I was already losing hundreds of dollars playing around with advertising. At this point in time, I still wanted to get a patent, which would be tens of thousands of dollars. I needed a couple certifications, we'll get into in a bit, which would also add to tens of thousands of dollars. And I wanted to exhibit at my first trade show where booths and travel add up to a couple grand. I only had around $25,000 saved up, so in other words, I needed money. Luckily, my social media first started taking off here. I think we were nearing 10,000 followers. I had 2,000 subscribers on YouTube. I had a working product, so it kind of felt like the perfect time to run a crowdfunding campaign. Now, crowdfunding is a tricky business. People think it's free money, but essentially all it really is a pre-order page that has a bit more social credibility behind it. Meaning telling someone, hey, I'm running a Kickstarter, come help, is a lot easier than, hey, I'm running a pre-order campaign on my own website. For example, you can get away with posting on Reddit that you're running a Kickstarter, but you'll instantly get banned for advertising if you send them to your own website. And at the end of the day, it's still going to be all you driving people to the campaign. Normally, if you want to raise many tens of thousands of dollars, you'll need to spend a bunch of money up front buying email lists, consultants, influencer deals, on and on. But there was no way in hell you'd catch me dropping half my life savings on this. So my plan was just to bootstrap, just like I did with everything else. The nice thing about having 10,000 followers, even if they are mostly engineers, is that clout is clout. It got me in the DMs with literally every single TMJ account I could find on Instagram, where from then it was just a matter of making personal connections, which is made so much easier by the fact that I genuinely have a great story as a patient building products for the market that they know firsthand is extremely underserved. When the Indiegogo campaign launched in October, I got as many of them as I could to buy one and share with their followers. The entire day of launch, I sat on this couch texting every single person I had ever texted in the last 4 years, literally random Tinder dates. I got everyone to post on their stories and share with their families and dentists. I got a post approved by the TMJ subreddit moderators. I posted on LinkedIn. I made 2 YouTube videos. And in the first 2 days, I managed to raise $7,000, more than half of the $13,000 I raised by the end of the campaign. I thought we were unstoppable until on day 3 of the campaign, I woke up to my biggest fear, an email in my inbox from If you didn't know, the FDA doesn't just regulate food and drugs, they also regulate medical devices. And you might be thinking, are you an idiot? You went this entire time designing myTMJ pen and you didn't even think to consider regulation? To which I would say, no, I'm not an idiot. And trust me, I did plenty of thinking about the FDA. And here are the facts. The FDA classifies medical devices into 3 classes, class 1, 2, and 3, categorized by risk. Class 3 devices are the highest risk. Think like implants, pacemakers, that kind of stuff, while class 1 are things like band-aids, wheelchairs, stethoscopes, much less risky. You've probably heard of FDA approval before, but there's a good chance you've been misunderstanding it the whole time. Approval is reserved for only those super high risk class 3 devices, a process that can take tens of millions of dollars. Middle of the road devices like class 2 don't need approval, but do need something called 510K clearance or pre-market notification, which is in the couple $100,000 range. While the least risky devices are exempt from both. both, but still need to be registered and compliant with FDA guidelines on labeling, manufacturing, design, you name it. Now, I'll be honest, I went through and probably still am on a roller coaster ride in regards to FDA regulation. When I first started this project, I didn't think myTMJ pen would even be considered a medical device. It's a heated massager, for Christ's sake. But a few months in, enough YouTube and Reddit and Instagram comments scared me into looking into it. And when I did, I clearly didn't know enough. So I plunged into weeks of reading through laws, guidelines, databases, and I came out with the fact that you technically don't need the FDA to classify your product. You can do it yourself based on what are called predicate device categories. Basically, you find the devices on the market most similar to yours and find out how they're classified. Except there was a lot more gray area to this than I expected. Believe it or not, there really are not many heated massagers out there, and none of the ones I could even find online I could find in the FDA databases. The closest device category I could find was called electric therapeutic massager, which at least had a couple heated shiatsu massagers listed under it. This code was a class 1 and exempt from 510K clearance. But then there was also a category called powered heating pad, which I couldn't find any substantially equivalent predicate devices for. But this category would be a class 2 device, although luckily also 510K exempt. I thought maybe I was missing something, but I even got in touch with a medical device consultant, and it turns out all of my analysis was right, and FDA compliance really is just a massive gray area. I read through all the regulatory guidelines, and even though it wouldn't be easy doing all the compliance work by myself, being a one-man company actually played to my advantage too, because I'm the guy making design decisions, I'm the guy approving design decisions, the guy maintaining equipment, and the guy manufacturing and labeling the final product. A lot of the FDA's rules are only meant to apply to big companies to make sure that there's proper communication and documentation, meaning it wasn't going to be as much extra work for me to do it myself as you'd expect. So okay, my plan was to register myTMJ pen as an electric therapeutic massager and do all the compliance work myself. Except there was a bit of a problem. You see, to register you need to pay an annual fee of $10,000 every single October, except the whole point of my Indiegogo campaign, which was in October, was to get the money to register. And you can't just pay early, no. If you pay a day early, you have to pay the full $10,000 and then pay another $10,000 as soon as October hits. There is not a chance I would let that happen. But bro, I'm a low-risk device who hasn't even sold 100 units yet. There's no way I would get on their radar, right? Well, that's why when I woke up to this email from the FDA, my heart sank. I thought, that's it, it's over. Shut down before I could even have a chance to make a difference. Only once I actually read the email, something caught my eye, and it let me take a deep breath. For some reason, they were saying it looked like I was marketing a medical device without FDA approval or clearance. And remember, those are the two terms reserved for high-risk devices. And as we researched, the product codes that even remotely applied to myTMJ pen were all exempt from a clearance and approval. Meaning even though I had no idea how they found out about me so early, they clearly just didn't understand what myTMJ pen did. All I had to do was justify that it didn't need 510K clearance or approval. Well, that's easy because it doesn't. But how would I do that? Because if I say it's a class 1 electric therapeutic massager, they'll ask, well then why aren't you registered? And I don't have $20,000 to throw around is not a legitimate reason, unfortunately. But because of this pressure, I had to pull something out of my sleeve that turned this whole interaction into a total silver lining. Basically, in my research, I had listened to a med device regulation podcast where I learned about the details of something called FDA's General Wellness Guidelines and how big of a gray area these guidelines created. Basically, at the end of the day, what's important is how you market the device and the claims you make. Supplements, for example, are general wellness products. They can't make medical claims, but they can say stuff like promotes mental clarity, which was really interesting because that's literally the kind of language every massager uses. They say improves blood flow or relieves tension. Never is it treats or cures. So I read through the actual guidelines and turns out you can mention specific conditions and disorders like TMJ disorder as long as you market it to, quote, to promote, track, and or encourage choices, which as part of a healthy lifestyle may help living with certain chronic diseases or conditions. Self-massage is indeed one of those healthy lifestyle choices that has been shown to improve quality of life for TMD patients, and up to that point, I never claimed that myTMJ pen treated or cured TMJ disorders. Just being safe, I pretty much was already following those general wellness guidelines. There are a bunch of other details I had to argue in my justification, but at this point, it finally made sense why so many of the devices I saw which combined heat and massage actually weren't in FDA databases. They just didn't market as medical devices. So I wrote up my response, and holy moly, was it fire. So I got it read over by some people I knew had dealt with the FDA before and sent it over. Waiting for the response was crazy. I literally had no idea what they'd say. They could agree, they could tell me to register, they could tell me to shut down. I was told I'd be waiting for weeks. But lo and behold, a few days later, I got a response. All I had to do was change a couple words on my website, adding May before my wellness claims, as in may release tension. This was kind of the best case scenario because now I didn't even need to spend the $10,000 and I had actual contact with the FDA to prove it. And with $13,000 raised from Indiegogo, I had the money to order batch number 2 and really start. The month after the Indiegogo campaign was mostly just about redesigning the website, collecting pre-orders, and hitting social media hard.
Plus, if you remember the issues with the rattling vibration motor, that was right around there.
But as soon as December hit, batch number 2 components arrived, which meant I could finally start running meta ads. And oh boy, they did not disappoint. I started scaling up slowly from around 20 a day to 50 to 150 to in January spending $300 a day on ads. At first I created ad-specific content. I went on Facebook ad library and tried to copy what seemed to be working for other companies. Plus I had a backlog of some videos that I already made about the device. But when things really started kicking was when I fully gave in to trust the Meta AI overlord and just dumped every single video I possibly could into one ad set. No top funnel, no bottom funnel, just one ad set that Meta had full control over. Because realize at this point, I've been posting every single day on Instagram for hundreds of days, often posting twice a day. I was a content machine, and a friend of mine clued me in that all of those reels should be tested as ads. Some of the best performing ads were what you'd expect. User-generated content from the doctors that I had relationships with in the TMJ space. But others I never could have predicted, spending thousands of dollars. Some of them I literally didn't even talk about what myTMJ pen was. In total, I was getting around 3 to 4 times return on my ad spend. In December, hitting $25,000 and then $50,000 in revenue in January. I shipped the last units of batch 2 in early February, which leads us to today. Ads paused and shipping halted. You might be wondering, why am I still selling batch to batch? Why can't I just order 1,000 at a time now and just never run out of stock? Well, that's the plan, trust me. In fact, I'm ordering 1,000 right now. I think this pause before batch 3 will hopefully be the last one for a while, and I talk about the reasons for it in this last episode. But mostly it's to really super duper finalize my circuit boards. As I hinted a while back, I found some pretty crazy electrical noise due to an underpowered filter capacitor, which I had to fix, and then send those boards to a FCC certification lab, which, by the way, we just got the approval results from. But then there was also a problem where the board only charged from a USB-A to USB-C cable, which caused me so much customer service headache. So I fixed that. My LEDs were too bright, so I added more resistors. And I had a problem where these red enamel-coated thermistors would short together against the aluminum tip if you tightened into them too hard. So now I use beefier rubber-insulated thermistors. The break also gave me time to write a whole-ass book about TMJ, which I genuinely believe is going to save people's lives more than anything else in the TMJ space, and I'm going to give it away for free as a lead magnet. And on top of all that, I got the Formlabs Form 4 so I can start testing if transitioning to resin printing is worth it, which I'll be doing by launching a limited edition, fully transparent myTMJ pen. I can't wait to start testing it because you guys seem to really like the aesthetic and quality, so I'll keep you updated. But yeah, I'm just super excited for it.
Honestly, I don't know how to end this in a non-anticlimactic way because this journey is far from over. A really strong knockoff competitor could come out any moment. We could get sued. We could get another letter from the FDA telling us that they changed their mind. Who knows? But the goal remains the same. myTMJ pen is only the beginning. Over this next year, I want to get it to $100,000 a month in sales and slowly start outsourcing manufacturing, fulfillment, marketing, all that so that I can get back to the drawing board and build even more products for the TMJ market. Because guys, I have a lot of really great ideas in these notes. So yeah, hopefully you'll be able to stick around and watch me grow as an engineer, product designer, and entrepreneur, and who knows, maybe you'll learn something along the way. See ya.